So this will be the tangent. So the tangent, and what we deal with the tangent, we deal with the gradient, right? So for each of the tangent, it has gradient, right? For each of the line has gradient. The formula of gradient anyway. Do you remember what is the formula of gradient, Vicky?
Which one is it? The y
Yeah, there you
two
go.
minus y1?
That's right. This is the basics, right? Y2 minus y1 over x2 minus x1, or the difference of y over the difference of x. Or we can say that the m is delta y over delta x. But how can you make sure that this line is a real tangent? How about if I just do it intuitively? It cannot be intuitive. It has to be a specific answer. So we need the help of differentiation or derivatives, or what you say in school, in your topic. Wait, forgot. Differentiation, that's right. So here, so the gradient is the differential, right? So it has to be so near 2 points differential. So I just want to focus at this point. Okay, I want to zoom this. Let's say this is the curve. Yeah, I zoom the curve like this, and this is point A. And in order to find gradient of a line, at least it needs 2 points, right? How about if I pick A with B? It can, but it's not accurate. How about if I change the point, the second point A, to the nearer A, right? Nearer to the A. So it has to be like this. But again, I'm asking, is it specific? Is it, will the gradient specific? No. You have to make it nearer, nearer, nearer. The nearer the 2 points, right? The nearer the 2 points, the more specific it is. Okay. So differential will be dy dx. This is not division. I want to make sure about this. This is only the pattern, dy dx. So this d is not written like this, wrong. This is the regular alphabetical d. This is d with like you write like this. Yeah, dy dx. This is the delta y, the small delta. This is the capital delta in Latin or Greek letter. This is delta for capital letter. This is delta also, but for the small letter. Okay, so this will be our approach in order to find the gradient. So dy dx. So for example, I pick 1 point here. So 1 point is x a comma y a. Wait, I think I need to draw another one so you can see properly. 2 points. There are two near points here. So I just pick like this. For example, this is x. I want to pick one point that is near to the x by h. So this is x plus h, right? This is x, and this is x plus h. What is the h? H is the difference. Okay, the difference between first point of first axis to the second axis, first x to the second x. Okay, how about this? This is functions of x, right? What is this? This is functions of x plus h, right? So to calculate the gradient, the red line, like I drew previously, this is the specific tangent. So the gradient or dy dx, right? M equals dy dx, or you can write this as well, up to you, depend on your teacher's teaching. But I think your teacher teach you dy dx is equals to the gradient formula. What is the gradient formula? Y2 minus y1 over x2 minus x1. Y2, this is 0.2, this is 0.1. F x plus h, right? This is y2 minus y1, right? Y1 here. This is x1, y1. This is x2, y2 over x2, x plus h, right? See, x plus h minus x. So this is the limit, the gradient. So dy dx will equals to limit when h near to 0, because the nearer to the 0, the better it is, right? Remember, the smaller or the nearer the points, the 2 points, the better it is. So fx plus h minus fx over, cross out, over h. Do you make sense of it? How is it, Vicky? You understand?
Yes.
Okay,
Okay.
nice. So this will be our basic understanding. Wait, it's too... Okay, I will send this to you later on. So let's go to the homework then. I have the idea or the simple way to do the homework. I think the homework is complicated. Why? Because we deal with the hard way. Because when you know the easy way to do the homework, or to do the differential, or to do derivatives, it will cut so much time. Wait, give me a moment. It will be more efficient. Here, let's do number 1. We use the first principle. That's what called first principle. Yeah. So the first principle of derivative is this. I want to rewrite one more time so you have the idea. Dy dx equals to limit h near to 0 of fx plus h minus fx. You have to memorize this over h. Okay, let's do number 1. 1a. So in order to solve this, you have to find fx plus h for each of it. B also. Right? What is fx plus h? You just change the x by x plus h, right? How about this? No x, so 5 itself. See? Piece of cake, right? And then what is this? 2 x plus h plus 5. Get it? You get it, Figgy? Until this part?
Yes.
Okay, so you have to do this first. This is the first step. Second step, enter the formula, or it's substitute with the formula. Fx plus h. Okay, what is fx plus h here? X plus h itself minus fx. What is fx? X itself. See? Over h. So what is this? Cross out. So h over h is equals to 1. That's the answer for number 1. Okay. Number 3, part B. Again, what is fx plus h? So you have to substitute this. 5 minus 5 itself over h. We don't know h. So the answer is equals to 0 over h. What is 0 over anything? 0 itself. See? It's quite simple. Yeah. If you just focus on how to substitute the answer or the formula with from the answer, from the question. I mean, wait, what happened? There you go. I use 3 colors. 1, right, and then second one, fx itself. See, so you can see the listings, right? Breaking down. I break down the formula. Part 2, step 2. I mean, this is step 1, step 1, step 2, and done. Okay, just focus. The green color, the green highlight, x plus h. Okay, so just 2x plus 2h plus 5, right? This is the green one. And I open the bracket, open, right? I just expand it, and then subtract with fx is 2x minus 2x plus 5. Put the bracket, almost. You have to put the bracket for every subtraction over h, right? So again, open the bracket. 2x minus 2x, you can cross it out, right? And then 5 minus 5 also cross out. The rest will be 2h over h. So the answer is 2. That's it, right? Any questions so far, Figgy, for number 1? 1A, BC?
So for 1B,
Yes.
So basically, to substitute, you put 5 into x, right?
That's right. So this is
So
5.
if you don't have the h, then where does the plus h go for
Okay,
1b?
because we don't have the x at all, Vicky. So there will be no difference for fx and fx plus h for question 1 part B. Why? Because we don't have to deal with the x. In this case, wait, I have to highlight it one more time. On the on question A and C, we have x, right? So you just change the x by x plus h. On question B, we don't have x, so what you can change? Nothing. Nothing that we can change, right? How about C? If fx if is 2x plus 5, so all the x is changed into x plus h. Get it?
Yeah.
So if we don't have x, don't change anything. Okay,
Oh, okay.
that's it. That's the way it works. Okay, let me know whenever you have any question, because one-on-one lesson is more. I think it's more effective. So you can ask
Okay.
everything. Don't think about, oh, that's a dumb question. No such dumb questions. Yeah. Number 2. Let's see. And let me know let me know if I'm too fast, so I can slow down. Okay. Now, number 2, again and again, we use this formula on the top side. That's the first principle. Okay. So highlight. This is the green one. Green means fx plus h here. Oh, yellow. I mean, this is yellow, right? The first is always yellow. Remember why? What is y? Y is always fx. Remember, fx equals 4 minus x. What is fx plus h? How can you explain fx plus h? You just change the x by x plus h. That's simple, right? Understand, Vicky?
Yes.
Okay. How about this? I just rewrite y is fx, so it more easily to substitute. I mean, so fx plus h is if x squared minus 3x, so every x changed into x plus h. That's the function rule, right? Square minus 3x plus h. Get the idea, Rachel? Hey, sorry, Vicky.
Yes.
Okay, nice. How about this, Vicky?
It would be
Quite long.
bracket 2 bracket x plus h squared
Yes,
plus x plus h minus 1.
there you go. That's nice. And what you can do now, simplify. Open the bracket first. Don't do like this. It's too much for you. And it will be so painful if you do just open and this is the final answer. This is the final answer. As long as you can expand, you have to expand. Okay. 4 subtract x subtract h. That's for fx plus h. And how about this? Expand. Oh my goodness, I hate this. X plus h squared. Right? Man, x squared plus xh plus xh plus 2xh, right? Plus h squared minus 3x, open again, plus 3h. Hey, sorry, minus 3h, right? Oh, I have to make the separator. Now, how about this? Again, 2x plus h squared. So just copy from the part B, x squared plus 2xh plus h squared, right? Plus open the bracket. Okay, you don't have to put the bracket anyway because it's plus, so subtract 1. Again, you still can make it more simple. 2x squared, so it's long because it's the first principle. First principle is required. H squared to h squared plus x plus h plus well, minus 1. Again, you cannot combine, right? There are no like terms, so just let it be. Okay, do enter or substitute. I just draw the green highlight, and then the green highlight, right? For fx plus h. Okay, so substitute to the limit formula. So what's here? 4 minus x minus h, subtract fx, the yellow, right? This is the green one, right? And then subtract bracket, yellow, 4 minus x over h, right? And then 4 minus 4, you can cross it out. And then negative x minus minus, so plus, again, cross it out, right? Negative x minus minus x. So the answer will be negative h over h. So it is negative 1. That's it. That's it. And that's simple. But for question B and C, it's more challenging. Why? Because you need to focus on one by one. Okay, and it's long. It's long. So the green color or green highlight fx plus h. Wait, I have to copy this and subtract by the yellow. This is the yellow one. And if subtract, always bracket. Pay attention. Okay, x squared minus 3x, right? Over h. And what you can do again, cross out. See, it's on and on and on. If you open the bracket, minus x squared plus 3x, right? No, 3h. Wait, yeah, 3x. So minus x squared cross out with this, and then minus 3x. See, minus 3x minus minus plus 3x. So okay, it's again cross out. If you ask me, is it always cross out on the right side? Mostly, yeah, not always, but mostly. Okay, so continue. What is the rest? 2xh plus h squared minus 3h. That's all. Over h. And what next? You can get rid of the h out of the upper formula, on the numerator, I mean. Okay, h bracket 2x plus, okay, divide everything by h minus 3 over h, right? And then you can cross out, and then 2x plus, what is h? Remember, h is always near to 0, right? You just can ignore anyway. Wait, I have to use the other color. It is ignorable. Just ignore. Because on the first principle, the h is near to 0, means it is always 0. Why I don't put here, as I said on your WhatsApp previously, if you put 0 over 0, it is prohibited, right? We have to get rid of the 0 first, or the h first. Okay, and then this is 3. Oh no, minus 3. Wait, give me a moment. 2x minus 3. That's it. Why it is ignorable? Ignorable. I think I miswrite it. No problem. 2x minus 3. That's the answer. In terms of x, yes, no problem. Not always number. It can be in terms of x. It can be even x squared in terms of x cubed, x power 4, and so on. Okay. Any questions, Vicky?
Nope, I understand.
Okay. So I don't know whether your teacher is quite straight or strict to the notation. It has to be limit. Yeah, it has to be like this. H near to 0. I don't know. Your teacher is require you to write like this as always or not. But this is for play safe. And there you go. Limit h near to 0. You have to write this on and on and on. This also. Okay. Okay, that's it. Number C. Number 2, part C. Again, use the what do you call it? Principal? Yeah, principal formula. Write down limit h near to 0, and use the formula, the green color, the green highlight, 2x squared minus 4x h minus plus 2h plus x plus h minus 1 minus bracket, right? The yellow one, because minus x, open bracket, 2x squared plus x minus 1, right? Over h. Okay, cross the unwanted part, or the variables that can be crossed out here, right? And then plus x minus 1 minus minus 1 also cross out each other. So the rest will be negative 4xh plus 2h, this is x, sorry, bad handwriting, and then plus h, that's all, nothing left, right, over.
I think that's positive for XH.
Oh, thank you. What did I do? Thanks. Wait, yes, it's positive. Thank you. Yeah, thank you. And I have to erase this. Okay, thanks. So what you can do now, limit x. What can you do now, Vicky? Any idea?
You can factor it with H.
Yeah, factorize the h, right? Okay. Oh, I think something wrong. Give me a moment. Square. Okay. I hate this. It's in detail. 2, I forget to write this power 2. So 2h plus 1 over h. That's right. And then what next? Cross out like this. And the next answer will be, the final answer will be 4x plus 2h plus 1. Since the h is near to 0, again, the h is ignorable, right? You just ignore this. 2 times 0 is 0. So the answer will be 4x plus 1. That's it. Okay. I think it's already clear enough. This is the most detailed answer. Okay, list down, separate between the x plus h and x. I mean, the functions of the green color, fx plus h and fx. Okay, after you separate it, it will be way more simple. You can determine the easiest way to do. Okay, just focus. I mean, just follow. Yeah. Okay, next, number 3, last number. I'll give you the idea later on if you have time. Oh, we still have so much time later on. They use a. I use x. No problem, yeah. Vicky, a and x, fx plus h and minus fx over h. Yeah, no big deal, because we use fx
My
anyway.
teacher also does.
Oh, your teacher also use x. Okay, nice then.
Yes.
Okay, glad to hear that, because sometimes for some students, the different letter makes different understanding, but anyway, it's stay the same. Okay. Again, for question A, you have to do it one by one. You can do it parallel, A, B, C, D, or A, focus, done, and then B, done, C, done, and so on. Use the first principle, find the gradient. What is gradient? Remember, gradient is dy dx, right? Gradient is always dy dx. So, as we already did just now, here. Okay, so I do question A and C. Later on, you do B and D. So pay attention first for question A and C. I just rewrite one more time. I'm quite OCD about this. And what is fx plus h? List down, right? 3 bracket x plus h plus 5, right? I just changed the x by x plus h. And I want to simplify this because we need to. Okay, and use the formula. Oh, it's given. Okay, glad. I want to change the a by x because I'm quite OCD person. There you go, there you go, there you go. Okay, write down. Limit. Oh, not x, h near to 0 of fx plus h. I just want to put a line because I want to separate the list down. The list. This is the list, and the workings. This is the workings. Okay. Okay. 3x plus 3h plus 5. Subtract bracket 3x plus 5. Again, I want to remind you. I won't bore. I will not get bored to remind you. If it's subtraction, you have to do the what you call bracket over h. The bottom part is quite simple. Top side is more complicated. Okay, again, I want to do it super slowly. I don't want to cross like this. I want to open the bracket. That's what I haven't done before. 3x plus 3h plus 5. subtract 3x minus 5, right? I open the bracket like this. So it's more easily to understand. Why it is crossed out? Yes, because it has the different sign, 3x and negative 3x, 5 and negative 5. And then the answer will be 3 itself, right? 3h over h. So limit h equals 3. So at x equals negative 2, so what is negative 2 here? Nothing to do with the negative 2 because we don't have the value that is in terms of x. So the answer is always 3. 3 consistent. If you want to see at the point here, what I want to show you later on is bang. Okay, Desmos. Nothing calculator. No, I use two screens, Vicky, so it's more more convenient for me. 3x plus 5, right? See, the gradient will be not changing for every point of it. See, so the gradient is always 3. How about the next question? C, yeah, I do see. X squared plus 3x minus 4. 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 See, when you want to find the gradient at x equals negative 2, it has to be like this, Vicky. Like this. So here will be 2. The gradient will be more or less like this. I do it intuitively, but when we deal with the what do you call it? The derivative, it will be exact value. Okay, so what is the question asking you for? What is the point? X equals 3. Oh, sorry, x equals 3. I used the same value. X equals 3. If x equals 3, the gradient will be about here. Oh, x equals 3. It's on top. Wow. Okay. Ah, man. Ah, there you go. It's super slope, super miring, you call. Yeah. So the gradient will be like this. But again, I don't want to do a graphical approach like this. Maybe see the tangent, but it's so positive. So the m is positive, increasing, and great, good, huge number. Let's try to focus. Let's try to prove it. Okay. Okay. For question C. Again, you have to. If you don't want to use graph, if you don't want to focus on graph, no problem. You can just focus on this. Fx, I just one more time. I just write one more time. X squared plus 3x minus 4, and fx plus h equals x plus h squared, right? Plus 3 x plus h. Maintain the focus minus 4. Okay, wait, not done yet. Not done yet. Not done yet. Okay, equals to open x squared plus 2xh. Remember previous expansion? Plus h squared plus 3x plus 3h 4. And then we cannot do any further. So just do the limit, right? Fx plus h, this one, the long one here. Okay. I do my trick. Okay. Subtract bracket of fx. I'm too lazy to rewrite. What happened? Oh, I haven't merged the layer. There you go. Close over page, right? Any questions so far? Okay, I just want to make sure about this.
No, I don't.
Okay, nice. Let me know whenever you have any question. Just cut my explanation at any time. Okay, open the bracket. If I open the bracket, okay, do it slowly. X square plus 2xh plus h square. I just realized if you are insecure about what you do, you can follow my idea. Open one by one. Yeah. But if you're confident enough, no problem. You can just cross out like I did on the first topic, on the first explanation, on the previous whiteboard. Minus 3x. Oh, see, wait, minus x squared. Yeah, there we go. Minus x squared minus 3x plus 4. Okay, I lost my focus just now. Plus 4 over h, right? And can cross out what you can. Square. See, mostly you can cross everything inside the bracket, but mostly, most of the time, not always. Okay. There we go. And then the rest will, what is remaining will be. Oh, okay. So 2xh, 2x. If you want to make the time efficient, you can get the h out of here. Just factorize h. Up to you. 2x plus h plus 3, right? 2x plus h plus 3. No more. Over h. Cross, cross. And then the h is ignorable here. So the answer will be 2x plus 3. But we have the x. See, we do this in terms of x. See, we have the final answer of x. So you have to focus here. Put it here. So f xn of 3, right, is equals to 2 times 3 plus 3. Where the 3 comes from the question. There you go. So that's for the 3, 2x plus 3. Okay. So just substitute the x by 3 in this one. So the answer will be 9, right? Yeah. 2 times 3, 6, 6 plus 3, yeah, 9. That's it. Any question, Vicky? I think if you can do this, you can do B and D. But what is the difference? The difference is only that's negative. Yeah. So pay attention on the negative part. Okay. So I think I need you to do this in about 10 minutes, maybe. If you are done, let me know. Okay, I will pause the recording. You can. Do you have a? If you have a. Okay, so if this, I can easily just put this figure 2 as 0. I can see it well. 2 minus 6x. So negative 2 minus 6x, and that's right. And x equals negative 2. That's all. Here, everything is right. Good job. Nice. So I will put this in. Wait, in Microsoft Word. I'll show you how to do. And we have 15 more minutes, and this is the easy way to understand the formula. Okay. So this is the first principle, and next we learn the second principle, the short way, the shortcut. How about if I want to ask you to find this here, power 5. This is so painful if you use the first principle. See, I cannot imagine how to solve this easily without with the formula, the first principle. There you go. Oh, can you imagine fx plus h? How to solve this? And so on, right? And so on and so on and so on. It will waste your time. So we do the shortcut. Here will be the shortcut. I don't think your teacher teach you this yet, because your teacher finished at 3D, exercise D, I mean. So here. If I have fx equals a times x to the power of anything, the derivative of, or fx sum x, this is derivative or the gradient or the dy dx, is a times n, you put the n below, times x power n subtract 1. Okay, this is the shortcut. Just memorize this, Vicky, so you don't have to use the limit x plus h and so on, wasting time. Just use this. Again, this is the idea. You put the n below and then you derive the value of n by 1. Derive means you decrease the value of n by 1, the power. Okay, let's see. So We have this 3, right? 5 going down, x power 5 minus 1. That's it. And minus 2, this is f x on x times 4. You put the 4 down, the power down, and if the power going down, minus 1. Minus 3, put the 3 below, x power 3 minus 1. Plus 4, right? We have 4 here, times 2, the 2 going down, okay. X power 2 minus 1, plus, we don't have any number, so 1, right? If we don't have any power, 1 itself. 1, right? So 1 times 1 times x power 1, subtract 1, plus, how about this? We don't have any value of x power 0, remember? If you don't have any value of x, the x power 0. 3 times 0, x power 0 minus 1. So the answer will be 15 x power 4 minus 8 x power 3 minus 9 x squared plus 8x plus 1. And then plus 0, right? 3 times 0 times anything is 0. So ignore this. That's it. Can you imagine if I do this, I pick one number, the previous number, or question C. Wait, where is it? Where is it? Where is it? Oh, there you go. I want to compare, just comparing the final answer and the working. I want to compare number 2B. Yeah, Vicky. So let's see this. This is the working, right? We have so much working. This is the first principle. By using the first principle, we know the formula of gradient will be like this. This is the workings, and this is the answer, right? We use the first principle. Okay. To do when we have the shortcut will be like this. X squared minus 3x. See, y accent or a gradient, you put the 2 below. Okay, we have 1, but you can ignore the 1 anyway. 2 below, and then 2 minus 1, see, 2x. And then minus 3, power 1, right? Put 1 below, and then x power 1 minus 1, right? As always, this is minus 1 as always. So how short it is if you memorize the formula? 2x minus 3. X power 0 is 1. See? 2 steps. How about this? Some step. We have to list down everything. But again, I don't want to. This is still useful, right? Because this is the basics of gradient or basic first principle of the derivatives. If you do the short formula, just simply put like this and then done. Okay. How's it, Vicky? Is it time saver? Yeah, this is a super time saver when we deal with the short formula. And this is so easily to understood. But as long as you know the formula, decrease and put below the n and decrease the value of the power itself by 1. As always, by 1. Done. So
X to the power of 0 is 1, right?
Yeah, x to the power of 0 is 1. So 3 times 1 times 1, right? But how about this? This is the 0 itself. 3 times 0, so it's ignore. You just anything times 0 is 0, right? So this is anyway. Yeah, actually, this is a 0. So how about this? 1 minus 1 is 1 times x power 0. X power 0 is 1. 1 times 1 is 1, right? 3 times 1 is 3. See? Get it, Vicky? Okay, nice. So we are one step ahead. I don't want to go too much, but I just want to prove that the limit or the limit formula, the first principle, is longer than the shortcut. So better memorize than use the formula. I cannot imagine if I do the power 5 thing, right? So as you can see, simple rule of differentiation is this. Wait, I don't have to do this. Just go to the conclusion. Wait, where is wait, where is it? Where is it? Wait a moment. There you go. See, this one. If fx equals x, the x for n, then x and x will be n times x for n minus 1. Done. Right? See? Addition rule, subtraction rule also, if it is a constant, it's always 0. Yeah. N times x. If I have c, what is c is constant times this. Yeah, up to you. Same. It's the same. So I think this book is give you more complicated way to memorize. I just give you one, the book give you 4, right? Okay, one only is enough. So see, this is the example. 3, let it be 4. 4 times x power 4 minus 1. See, 4x cubed. Then here 3 times x power 3 minus 1, 2. Decrease the value of power, the power by 1. And then minus 5, 2 below x power 1. So can you imagine if you use fx plus h, so 3x plus h power 4, and you have to expand. Okay, the 4 is too long, wasting time. So this will be the shortcut, and this is the easiest way to memorize formula. Wait, there you go. Dy dx when x equals 2. If you after you get the point, oh, over, what is over? How can you do over x? Remember the rules of indices. 1 over x can be written as x power -1, right? So if I want to derive 4 over x squared, for example, so I have to change this first, the notation become 4x power -2, and then we can do dy dx, or the derivative. Let it be 4 -2 going down times x power -2 minus 1. Some of the students, first timer, -1. Wrong, yeah. This is -3. Okay, -8 x power -3. That's the way. Okay. See. So the derivatives will be 2. This is what accent. X power 2 minus 1 minus 4 times -1 going down. X power -1 minus 1. Right? See? Become -2. And this will be the answer. And when x equals 2, just put the x as 2. See? 2 times 2, 4. 4 over 2 squared, 1. That's it. You just insert and substitute the x, and then you will get the value of tangent itself. The tangent, or the gradient of the tangent. Okay. How about square root? There you go. Square root is x power half. Remember? If over square root, x power -half. So you have to look at the indices rules. Because the indices rule is the basics. Okay, how is it, Vicky? Do you understand so far?
Yes, I think I understand so far.
Okay, so this looks hard, but no, it's quite simple. Just focus on the formula of the short formula. Again, I don't want to go further, but I guarantee that your teacher will explain you that easiest way, that easy shortcut. Okay, we still have about 5 minutes. I think, yeah, you can do the exercise 13E. I mean, just do the easiest one. So in order to practice, so you have time you have 5 minutes to practice. I will stop the recording. The video will be given in YouTube. Yeah, I will send the link on our group.